Hey everybody, Robert Wolfert here. Robert Wolfert, the man with the worst haircut, the worst COVID-19 lockdown for a long time, not cut it or not professional cut it haircut. Yeah. And I welcome you to another episode of Random Linux Tools Explained. It's all about Linux command line tools you can use for your day-to-day work at the Linux command line. And I want to explain such tools to you. I want to talk to you. I want to tell you how these tools can be used for, what these tools can be used for, and how you can use these tools, if there are some interesting command line options, if there are some interesting things related to these tools. I can tell you from my experience. And to make it a little bit more interesting for you, I have added a small challenge for me. And the small challenge is that I don't know beforehand what tools to explain. Instead, there is always a randomly chosen tool. There is a tool chosen randomly, and then I have to explain without any further preparation the tool to you. What it can be used for, how it can be used, and if there are some related, interesting, useful, related information around this tool. So let's start directly again by sharing my screen. Here we are, and let's go to the tools directory, and within the tools directory I have a list of tools within this file, tools.txt. 121 tools to be exact are within this file, and I have this script choosetool.sh that gets me, or that gives me, one of these tools randomly. So let's start by choosing a tool. choosetool.sh. Mixing the tools, waiting, and the winner is now mkfs. Okay, mkfs as a tool for creating a file system. mkfs stands for Make File System. Make File System is the formatting tool. If you have a new disk, a new empty disk on a system, and you want to format this empty disk, you want to create a file system, you want to use this mkfs tool within your directory tree, then you have to create a file system. You use the tool mkfs. So let's have a look how I could use this tool without a different file system to create it all in all without an additional disk. I don't have an additional disk on my demo system, but I want to create a loop file system. A file system within a file that's on my current, or within my current directory. Let's try this out. First, for everyone who joins us late, let's include a banner. Tool on stage now. mkfs is the tool I want to explain now. So first, let's create a virtual disk. Let's create an empty file, and then let's create, or let's use this empty file just like an additional disk. So let's create an empty file. For creating empty files, you can use the dd command. It stands for disk dump. Let's create a file, disk dump, and I want to create this file, and this file should contain only zeros at first. So I take an input file. This is the first parameter here for the dd, for disk dump command, and I take an input file dev 0 and an output file, and the output file is named, let's choose a name, virtual disk image. So what this tool does now is it reads blockwise from the file dev0. This is a device file that only generates zeros, yeah, and it takes these zeros and it writes these zeros into a new file, virtual disk image, within the current directory. And because I don't want to fill up the current directory completely, I have to say how many bytes I want to transfer. Yeah, and I do this via the block size parameter and via the count parameter. So I take a block size of 1024 bytes. This is a kilobyte. Let's take a block size of 1024 kilobytes. Yeah, K. And let's do 500 of these blocks. So as a result, we would have, or we should have, 500 megabytes file. Yeah. So let's start this. Let's read from dev0. Let's write into this file only the zeros, 501 megabyte blocks, and it goes really fast. 524 megabytes written, yeah, into this file, ls-l. This is my virtual disk image file. And now let's create a file system. Let's create a file system mkfs. Typically, you won't create a file system on a virtual disk image file. Typically you will create a file system on a disk that was appended. It was newly appended to your system. And these disks that are added, appended, attached to your system, these disks are available via device files. And typically these device files have a name like dev SDA, dev SDB, and so on. And then you will typically create partitions via fdisk, for instance, for this new disk. Yeah? And then you will have a device file for every partition on the disk. Yeah. So let's again start with, or let's start this time here with a whiteboard. Yeah. So you typically will append a disk to your system. This is a disk, and the disk will have the name dev SDB. For instance, this is a newly created disk, and then you will call fdisk to create partitions. Yeah, with the help of fdisk, you will create partitions, and these partitions then are reachable via dev SDB1, the first partition, the second partition, dev SDB2, and so on. Yeah. So these are then the partitions, and these partitions can be used to create file systems on them. Yeah. So you can use the mkfs tool to create a file system. Or let's write, we have a file system on this file system 1, and then we have a second file system 2 on dev SDB2. Yeah, let's take an arrow. First file system on dev SDB1, second file system on dev SDB2. Yeah. Okay. And these file systems these file systems can be created via mkfs. Now we have the tool mkfs, and there are multiple file system types you can choose from on a Linux system. On a Linux system, you have file system types. For instance, you know file system types, the vfat file system or vfat32, yeah, for Windows systems, for instance. Yeah, you won't use these file system types for Linux systems natively. Yeah, but if you want to create a file system on a USB stick, for instance, then perhaps vfat or vfat32 would be a great option. For Linux only file systems, you would typically use the ext3 file system or the xfs, or you would use, for instance, the ext4, yeah, the successor of ext3, or sometimes btrfs, renewable. Yeah. So here are some file system types, and you can use mkfs to create these types of file system. And typically you will call mkfs in this way, that you say mkfs-t. This is the type of file system I want to create, and I want to create a type of file system on this device file div as the xy. Yeah, let's write it in this way. So with this command line, you can create a file system. You can create a file system of a special type or of a named type within or on a partition. Yeah. Okay. Now I don't have an additional disk added to my system. Yeah. Instead, I have created a file, virtual disk image, and now I use this file, virtual disk image, like it was a file for a partition. Yeah. Just to showcase how mkfs can be used. So now let's try to create a file system on virtual disk image. mkfs virtual disk image. Yeah. I call it, and you see mkfs creates something, and the mkfs tool creates by default here on this system an extended 2 file system, a very old extended 2 file system. The mkfs tool is only a wrapper. It's only a wrapper for all the other tools that can create file systems on its own. So if you run mkfs, you typically will tell to mkfs what file system type to create. So let's create a file system called ext4 within virtual disk image. Yeah, and what you see is a warning: virtual disk image contains an ext2 file system. Proceed anyway. Yes, I want to proceed. Yeah, okay. Or let's say I want to create an xfs file system, mkfs-t xfs. Yeah, I again need to force the creation of the file system because the mkfs tool sees that there is already a file system available or created within this disk, or so I have to use the -f command line switch for forcing the creation. Yeah, and now the file system is or was created. And I can even create, if I want to, an old MS-DOS file system here. Yeah, or I could create and vfat 32 file system. No, there isn't a vfat 32 or vfat 16. Okay, so no, there isn't such file system to create, or you cannot create here such a file system. What you see is that mkfs isn't a tool that can create every file system for a Linux system, but it is only a wrapper. It is only a wrapper to call a separate command for every file system you want to create. Yeah? So if I create, or if I call mkfs-t ms-dos, it starts a tool mkfs.fat. Yeah? Or if I call mkfs-t something, it tries to start something. What's the name of my file? Virtual disk file. Yeah, it tries to execute mkfs.something. Yeah, so every time you call mkfs-t with some name for a file system type, mkfs itself calls a file mkfs.something. Yeah, and this can be really great used via or with the tab, with the help of the tab key. So if I know there are some commands starting with mkfs dot, I simply can use the tab key to show all these commands available. Yeah, mkfs dot, and now let's hit the tab key. Let's hit the tab key, and nothing happens because there are multiple commands starting with mkfs dot. So let's hit the tab key a second time, and now you see every tool installed or every command available on the system with a name starting with mkfs dot. And these are the file system types you can create. And these are the file system types you can create directly on the system. So I can create a btrfs, I can create x2, x3, x4, I can create a FAT, I can create MS-DOS, NTFS, and so on. Yeah. If some file system type you need is missing here, then you just need to install a software package that contains these tools. Yeah. There are packages for every file system tools you can create from your Linux system. Yeah. So you can call these mkfs tools directly. You don't have to use the wrapper with -t. You can call these tools directly. So if I want to use the ext4 file system type, yeah, let's call directly mkfs.ext4, and now let's create it on virtual disk image within this file. Yeah, mkfs.ext4 virtual disk image. Let's run it. Again, the warning, there is already a file system on this file. Yes, I want to proceed. Great, and now this file system was created. Yeah. Now I have here a file, and this file contains a file system. So what can we do with this? What can we do with this? Yeah, we can just mount this file system into our directory tree. Yeah. On a Linux system or on any Unix-like system, there aren't any drive letters like C:, D:, and so on. You have to mount a disk you want to have access to into your global directory tree. Yeah. There is a tool that is called mount, and with this tool you can just mount a file system on a disk, yeah, into your directory tree. Typically you will call it like this, let's have a virtual disk image and let's mount this to somewhere. And for instance, let's mount this to /mnt. Mounting is available for the root user only, or this free form mounting is available for the root user only. So if I want to choose a file system on my own, and if I want to mount it somewhere into some directory I have chosen, then I need to be root on the system. So I need to call it via sudo mount virtual disk image to the directory /mnt, and voila, it worked. I noticed because there wasn't any error message. Yeah. So now I have within the directory /mnt everything available that is within my virtual disk. Let's copy something there. I need again sudo because I don't have any file system permissions or directory permissions into the mnt directory. So let's copy the etc passwd, let's copy the etc group file, let's copy these files into the mnt directory. Yeah, now you see mnt as a directory contains group and passwd. Now let's umount this virtual disk image. Let's umount this, umount /mnt. Again, we need to be root, so I call it via sudo. And now let's have a look again into /mnt, and now it's empty. Yeah, so this is my partition, my virtual disk, my virtual partition file I have created via mkfs. A file system on or within this file, and to have access to this file system I need to mount it, and mounting can be done via the mount tool, and the mount tool simply takes two parameters, at least what you want to mount, and what you want to mount is typically the file, the device file, the sdb1 for instance, yeah, and you want to mount it somewhere, for instance into the directory /mnt, and this is the mount point. Yeah, this directory is the mount point. This mounting is only temporary here, and this mount point is therefore chosen if you want to add this disk for a special service, for instance, for your database needs more space and so on. You will typically mount this somewhere else. Yeah, for instance, into var data something database or something like that. Yeah. So, but I wanted to explain this tool, mkfs. And this tool can be used to create file systems, of various types on an prepared partition, or directly on dev.sdb if you want to, or within a file. Yeah, and I have created this file via the dd command here. Yeah. Okay, so that was the mkfs tool. Let's choose a different one. Again, go into tools. Let's start, choose tool.sh, and mixing the tools. And the winner is now group mode. Okay, group mode, we had group mode already in session number 2, I think. So I can choose tool. No, I do it short. Here, group mode is a tool for modifying groups. For modifying groups on a system. You have defined multiple groups on your system. These groups can be found within etc group. Yeah. And all these groups are used for giving permissions to some file or directory, yeah, something someone can do with something. Yeah. And most of these groups here on the system are typically used for services that are running. Yeah. And these tools or these groups can be created via group add. They can be removed via group del, and they can be modified via group mode. And what can you modify of a group? Which properties can you modify? You can modify the name of the group. Yeah, this is the first part here. Then you can modify the user and the group ID of the group. And you can modify, here is an X, you can modify the password that is set for the group. You can really set group passwords, but it is really not a good idea to do this. But this is group mode can be used for. On some distributions, you can even use group mode for modifying the member list for each group. But here on this system, this is, I think, an Ubuntu system. On this Ubuntu system, yeah, you cannot modify the member list. If you want to modify the member list, you have to use the user mode command to add a special named user into a group. Yeah. So let's have a look into the output of group mode --help. You see here you can change the group ID of a group, you can change the name of a group, and you can even set a password for the group if you have an already encrypted password here. Yeah. So one thing I want to do here is, let's have a look into etc group. I have here a group. Now let's create a new group to modify it later on. Group add test group. I need root permissions to do this, so I call it via sudo group add test group. Let's have a look. The last line of etc group tail-n1 shows me only the last line of etc group, and you see this test group is created with a group ID of 1003. And now let's change the name of the group, and let's change the user and the group ID of the group. So group mode --help. Yeah, let's change the group ID -g. Group mode -g. Let's choose the 2002, for instance, as the group ID for the group test group. This was the name of the group I've created. Yeah, again, let's call it via sudo. Yeah, or I will get a permission denied. Now it worked. Yeah, and let's have a look at the last line of etc group, and now you see test group now has the 2002 as the group ID. Let's rename the group. Let's rename the group via, here you see it, the new name -n. Give the group a new name. I want to call group mode with -n, and test group 2 shall be the new name for test group. Let's do it. Let's have a look if it worked, and great, it worked. Yeah. Okay, so this is the group mode command, or what the group command is used for. Yeah. So let's take another tool. Are there any questions within the chat? No, there aren't. Let's take a third tool today, yeah, because this tool, group mode, was already on stage in video number 2, I think. Okay, let's call choose tool.sh, mixing the tools, and the winner is rsync. rsync. Great. First, let's edit the screen. Let's edit the banner here. Now rsync. rsync. So great. Yeah, tool on stage, now rsync. rsync is a tool for synchronizing a directory tree or for synchronizing a file from a source to a destination. Not to synchronize in both directions, yeah, but to copy changes from a source to a destination. That is what rsync is used for. rsync, the R in rsync stands for remote. This is a remote synchronization tool, and you can use rsync on a local system too, if you want to. Yeah, just to demonstrate how rsync works, let's synchronize a file to a different directory. Let's synchronize the file virtual disk image, rsync. Let's synchronize virtual disk image into the directory tools, for instance. Yeah. Take some time, and now within the tools directory, I have a copy of the virtual disks file. The virtual disk file, yeah. ls-l virtual disk image and tools virtual disk image, a one-to-one copy of this file. And I can do this as often as I like. Yeah. Call rsync, and I can have a one-to-one copy. What's the difference here between rsync and the copy command? Yeah, I could simply call the copy command to copy a virtual this huge file into this directory. Yeah, the really great benefit of rsync is that rsync can or will transfer only changes within this file. Let me demonstrate this. Let's call rsync with the -v command line switch that stands for verbose. So rsync says what it transfers, and it transfers here 524,000 and something bytes. Yeah, so the whole file is transferred or is copied over to the target, yeah, into the new directory. And now let's change, or let's append something at the end of the file. Let's append something at the end of the file. I do this just via. Is it mounted? Is it mounted? Let's umount this. Sudo umount /mnt. Okay, was not mounted. Let's append something onto this file. Only some line of text. Yeah. Let's append it to the virtual disk image. Now the virtual disk image is 6 bytes larger than the copy. I've created before. And now let's call rsync again. Yeah. Now let's call rsync again. And what you see here is the total size. Okay, everything was transferred. Okay, it doesn't work out here. We have sent the whole file. What the hell did we send the whole file? Let's try this out. Let's try this out via the network. Why the hell is rsync not transmitting only the changes? By default, rsync only transmits the changes between files. Let's try to demonstrate this in another way, in a different way. Let's transfer some files over the network. Let's transfer some files over the network, and let's use an SSH connection for this. rsync was implemented many years ago, and if you wanted to use rsync, you had to use an rsync server. But today you don't have to use an rsync server anymore. You can instead use an SSH connection. You can leverage, or you can build up to a remote system. So let's call rsync. Let's call rsync with -v again. Let's now transfer the whole directory, our whole directory home robot, to a different location, to a remote system, 127.0.0.0. Let's transfer it to localhost. I don't have a demo system here on the remote network. Yeah, let's do a connection to localhost, and let's copy the whole file system or the whole directory into the TMP directory there. Yeah, this is the idea. I want to transfer my home directory. I want to back up my home directory to a different directory here. So let's take this as a template. First, let's remove the big file here, the virtual disk image. Otherwise, my disk would have filled up completely. And now let's call this rsync tool. So, rsync will now build up an SSH connection to this system, to localhost, point 1, yeah, to localhost, and will synchronize this directory into this directory. Yeah, and rsync will typically only transfer files, not directories, recursively. So if I call rsync this way, you will see an error message, or let's start with, okay, I'm not prepared at all. Let's start over again. I don't have a password set. I don't have a password set for the user robot. So let's take a different user. I have a password for on the system. The user Wolfhard is the user I use for connecting directly to the system. So it has a password. I build up, I connect to this remote system, to the local host. I authenticate there as the user Wolfhard, and then I transfer locally my directory home Robert into the directory TMP on the remote system. So let's try this out. Let's do this. I build up this or establish this SSH connection for the first time. So I have to say that I know the key. And I have to type in a password. Now I'm connected and all the files were transferred. All the files were transferred. Here you see, skipping directory Robert. rsync by default only transfers files, or it only wants to transfer files. If you want to transfer directories recursively, then you will call rsync typically with the -r command line switch that stands for recursively. Please transfer the files recursively. Then there are some more interesting command line options for rsync. These command line options are, for instance, a G for preserving the group membership. We have a T for preserving the timestamps. We have, I think, an M for preserving the mode of the file, the permission flags of the file. And if you call rsync to transfer data for a backup from one source to a destination, then you want to preserve typically everything that can be preserved. And this can be achieved via the archive mode. The archive mode can be started or activated with -A. So you don't have to remember all these command line switches like recursively and preserve modes and preserve timestamps and preserve owner and group and so on. You just need to remember the A command line switch for the archive mode. And I want to see what's going on here. So I add the verbose command line switch. And now again, let's connect to the remote system. And you see every file is transferred to the remote location. Let's call rsync again. And now you see nothing is transferred, or 555 bytes are transferred only because there was only a check if the files are the same on the source and on the destination. Because rsync only transfers differences. So let's create a new file. Let's create a new file, touch test 1 for rsync. And let's call rsync again. Let's authenticate here, and you see only this file is transferred. Send 629 bytes. Only the changes will be copied by rsync. Let's test this now with our big file, with our large file, this virtual disk image file. Let's again append something to this file, virtual disk image. And now let's call rsync again. Let's authenticate. And okay. We send the entire big file. No, we don't send a file. You see, we sent only 107,000 bytes. we didn't send the whole file. The whole file has a size of 500 megabytes. Yeah, we only sent 107,000 bytes here because rsync simply compares both files on source and the file on destination. It compares them block-wise, block by block by block, if there are any differences. If there are no differences, we don't need to transfer anything. And if there are differences, if we reach the end of the file, then there are differences. And then we need to transfer this last block, for instance. Yeah. Okay. And this is really useful if you use rsync via a network connection, a real network connection. Yeah? In this example, I use localhost, but if this is a different host, different system on the internet, a different system you have within your network that is hosting the backups, for instance, yeah, then rsync will really only transfer the changes, the changed files or the changed properties of the files. If I simply touch, for instance, the file, I touch the file virtual disk image, and now only the meta information has changed. Yeah, let's have a look. Let's have a look at the source file. The source file is here, virtual disk image. The destination file is within the TMP directory. There we have the backup directory Robert here. Here we have this file virtual disk image. Let's see the timestamps, and you see here my source file has different timestamp. And now let's call rsync. Let's call rsync, and only the changed timestamp will be sent for this virtual disk image. Yeah, the system compares the files on the source and on the destination, and therefore it takes some time, but there are really only few bytes transferred between the two systems. Yeah, and now the timestamps here are equal. Yeah, so this is rsync can be used to transfer data from a source to a destination over a network. Over a network link, you only need to have SSH, a possibility to connect via SSH to a remote system. You need to have write permissions to the destination. Yeah, and then rsync only transfers if you call rsync for a second, for a third, for the fourth time, and so on. Rsync only transfers the changes that were made since the last call of rsync. Yeah, and therefore the name sync. It synchronizes the files from the source to the destination. Yeah. Okay. Hopefully I have explained it so that it was understandable what is rsync or what rsync can be used for. Yeah, we had rsync, we had groupmod, and I forgotten mkfs, the third tool. Yeah, we have these 3 tools today. If you want to know more about such tools like the ones we talk about here, have a look at shelltoolbox.com. There can you get my book, the Shell Toolbox, for free plus shipping. The Shell Toolbox that gives you really every tool you need for your day-to-day work, with explanations, short explanations, with example calls. Yeah, if you're interested, just have a look. Yeah, now it's time to finish this session. See you next time.